Hi, this is a long review version of the paper towards zero-label language learning, which is mentioned in Dr. Jeff Dean's Google Research 2021 annual research report. And you can see in the table 1, this paper proposed a method called the Unsupervised Data Generation method, which outperforms the human performance and previous software system, which is unsupervised. It can get 90.4% compared to the human and the previous software system. And also, under the unsupervised case or few shot case, even somebody can use the GPT-3 model, which is significantly larger than the model used in this paper. The system can still outperform the few shots learning method. Okay, let's see what they do. First of all, I think they also talk about the few shot inference. I think it's necessary to share a quick overview of what is a few shot inference with you. And you can definitely see the equation number 1. Where's it? Yeah, here. Let me write it down here. And suppose you have a query or input XQ, and you suppose you have a few shots, and suppose T is your task, and the few shots mean there are mainly 2 cases. One is 0 shot, which means you have nothing. This is just empty, okay? Or most time is 1 shot, means you have I think they talk about a pair, okay? You probably have X shot 1, Y shot 1. This is just one pair. Or you may have maybe 5 shots. You can have 5 pairs, right? And these input all summed up together as a condition. So you can get a probability model of predicting the Y. And you can have many Y predictions. Suppose you're using a autoregressive model, then you will have a beam search scenario, right? At every output index, suppose this is n plus 1 time n plus 2, then you have lots of y's, right? This is y, yn, this is yn plus 1, yn plus 2, because each yn is going to be fed into the input and generate an extra y, and then you see the yn generation is dependent on the previous yn minus 1 or yn, okay? Then you're going to have a beam search, this stuff. And then you can try to have the y that can make the y maximum, okay, or the probability maximum. And it has to be pointed out that the few shot learning inference do not have any gradient update, which means they use some pre-trained model like the BERT or T5, but it does not try to update the parameters in the model. Why? Because there are too many, because the number of shots are too few. You end up with overfitted model if you just try to use tune model with a few shots. Okay. Okay, let's talk about the method they're trying to propose is called a unsupervised data generation. Let's take our equation first. Again, the first condition is task, and the second one is a data set. I will talk about that later. The third one is a description of the pseudo label, predicted label. What does that mean? What is the description of a pseudo predicted label? Let's take a look at the equation. Let's focus on the third input, sample input. The task is task is connected sentences, and you can see there is a there is a one example or one shot example. The input is the woman repaired her faucet, and the output is the faucet was leaky, and the connection is unknown. Okay. Well, what is the label description? Unknown connection. I think this is the description of the label. Okay. Or you can see the red colored text is the label description. For instance, this is the next one. This next one is an unlabeled input. Okay, so it doesn't have output, right? No output. So you can see the input is my computer screen went black. Probably it's broken, right? And the connection label is because of what? So you have to come up with a output that serves as the cause of the input. That's my understanding. Definitely the cause could be the power went out. Okay. So now I think you guys are understanding what does the description of the predicted label mean. Okay. It does not use the it does not use the label of the prediction. It uses the description of the label, which is not just a class label. And this is a textual sequence, right? This is smart. I will tell you why later on. Let me zoom out. Now I think it's time to talk about what is the U here. U, the textual set, it's a prompt. Here, it's a prompt consisted of a small set of k unlabeled example. I mean, it's to me, it's my understanding is the input. It can be from x1 to xk. And they use all these three conditions to serve as a general condition or given condition to get or define a generative model. You can see equation 2. It's a generative model. Generate what? The model can generate x first of all, the model forms a distribution of the possible x given the three conditions, right? Definitely the model means there is a base model, something like the bird or T5, okay? And they can generate x. So they will sample the output of this model. So you can see, compared to the few shot generation, which generates the predicted labels, what they're generating is they generate the input. And why they're trying to generate input other than predicted label y? Because they mentioned that because lots of time they think, or they mention that the labels often emerge prior to the input in real-world web documents, which might be true. And they're saying their drawing is from that is that few-shot inference can force the target, the language model, to generate on text distribution that are inconsistent with its training data. Whether it's correct or not, the few-shot inference doesn't work as good as the UDG. You can see while they're using this model, they requires no fine-tuning step of the generating model. What do they mean? They mean they use a generating model, which is probably BERT, T5, or even GPT-3. But you can see that the model is task agnostic. And they're just using a general model by feeding the task label, the unsupervised, the unlabeled inputs, and the description of the predicted label into this general model. And then you now you can see it's smart for them not to use a class label, but so they use the textual sequence, which means you can see all these things are text. Okay, the task is, I think maybe the task is not text. Definitely you can specify the task as a label to the BERT model. That's my guess. Okay, but all the rest of you and the description, they are text form, so they can always be fed as a input text to the BERT model, right? But if you have a class label, it will be troublesome for you to feed a class label into the BERT model, I think. Okay. And that they also stress that it is not their intention to leverage the language model to perform generative tasks. No, because they want to generate the input. They only want to synthesize some data. So why do they want to synthesize data? Let's see the figure 1 again. So once they have the XG, okay, they can pair the XG with the YG. They can have lots of these pairs, probably gazillions of these pairs. For instance, I can have 100 million pairs. Then have what? I have a synthetic data. Synthetic data or training data, right? So I can use this data to fine-tune a prediction model, which is known to everybody, right? It's fairly vanilla prediction network by using the synthetic data to fine-tune it. And they also propose something called NLA. It's called a noise label annealing. They mentioned that this is in the appendix 1. I did not see. Yeah, I think this is the first time I read it. I think it's very ad hoc. This is it seems that this is an ad hoc method for me. They try to remove a synthetic data pair if the pair does not conform to certain criteria or fall below a certain threshold. Something like this, right? This is kind of like a magic here. Okay. So now you understand the procedure or the proposed unsupervised data generation. Now that let's take a look at how well they work. First of all, you may say, okay, remember in the few shots learning, in this location, they have the L few data set. Sometimes they just put one shot in there or maybe two shots. Not many, right? It's working. Now for the UDG method, how many K inputs or unlabeled inputs should I put there? Well, their experience is that the bigger the better. You can see in the table 3, when they're using the maximum K, which is 32, they got the best result. But I guess if the K is too big, then the model became slow, I guess, because you're gonna be feeding a lots of inputs textual sequence into the BERT model in one input. Yeah. And they did experiments on how many example they should generate or pairs they should generate per class. It seems that to me they only need to generate about 100 like 100 examples per class, so they can get very good accuracy. This is interesting. They only need to generate 100. I thought they may need to generate way more than this. And that they talk about the NLA is robust. I guess it removes a lot of noise. Removing noise is important. And if you look at the table 4, you can see under the supervisor condition, their proposed method together with the fine-tuned T5 model. T5 is bigger than BERT, but it's way smaller than the GPT-3, right? So it not only outperformed the human being's performance most of the time significantly, and sometimes they're slightly behind the dBERTA. I don't know what is dBERTA, but they're way better than the GPT-3 under the unsupervised condition, even though their T5 model is significantly smaller than the GPT-3. Right? And consider that, few shots means that you still have one or two labels, right? Which is better than unsupervised learning, which is indeed 0 shot. And you can see that this one is slightly worse compared to the few shot. This one is better. This is worse. There are some cases that they're significantly worse than the GPT-3. So my guess there's something they have to improve on. Okay. I guess I will stop here. Thanks for watching.